Good morning, class. This is Mr. Walker here with our lesson for today. We are jumping back into proofs, and it's been a minute since we've done some of these. So, here's what we're going to do we're going to go through a couple of proofs together. Make sure that you're following along with us. And without further ado, let's jump into it. All right, so quick review about proofs as we've talked about before. We have three different ways here that prove that two triangles are in fact similar. So these are going to be our bread and butter that we're going to be working with today. So first off, let's talk about what each of these in fact do. So talking about the angle postulate, let's explain this first. So if two angles of one triangle are congruent to two angles of another triangle, that means that they are similar. So we need two angles that are congruent on two different triangles. If they are the same, then that's going to mean that they are similar. All right? You just need a two. You don't have to really worry about the third. If two of them are the same, the third's going to be the same also. Okay? So you need at least two. All right. Next one we got is side, side, side. Note the name, side, side, side. So you need three sides, folks. So if all three sets of corresponding side lengths of two triangles are proportional, then the triangles are similar. You need three sets of sides, and they all need to be proportional. If they are not, then that means that they are not similar. So you have to be able to set up a proportion. We've been dealing with those for a while. Please don't tell me that you don't remember that, folks. All right, lastly, we got a side, angle, side. Just like I said, note the name with this, note the name with this. You need a side, then an angle, then a side, in that order, okay? So, if an angle of one triangle is congruent to an angle of another triangle, and the side lengths, including these angles, are proportional, then the triangles are similar, okay? So it has to be two sides, and the angle that's in between those sides have to be proportional. Sorry, the angles have to be the same, the sides have to be proportional. My bad. All right, so we got three examples right here that we got to go through and hit. So let's hit those up. Okay. So are the triangles similar, and states how? So first, note the sides that we got here. Note the angles that we got here. These are how we're going to be able to determine whether or not they are in fact similar. So first one we got here, we got 108, 41 on one of our triangles. We got 108 and 31 on the other one. So for us to be able to really determine this, we have to keep in mind for triangles, all three angles add up to 180. So what we're going to do is we are going to go through and find what the other two angles are. Our other two angles, if we go through and subtract these other lengths that are given from 180, that gives us that the triangle on the left has an angle of 31, the triangle on the right has an angle of 41 for its missing angle, which means that these two are in fact similar because they have two angles that are the same. So that means that this is yes, and since they have two angles that are the same, aka congruent, this is similar through the angle postulate, or AA for short. All right, next one that we got right here. You may not remember this notation. This is from a while back. These two lines here, whenever you see this marking on the side of a shape, that means that this is parallel to this. So these two angles, not angles, these two lines here are both parallel to each other. And remember, if you have parallel angles, not parallel angles, parallel lines, my bad. You have parallel lines, that means that you have some angles that are set up through this. Why you gotta meow on the mic? Sorry, my cat's right here, folks. All right, so if you notice, both of these triangles have this top angle that is the same. See, the small triangle has this top angle. This big triangle that's around the small one also has that angle. And we also have these angles here are the same. We also have another set of angles that could be the same if you also include this one to this one, okay? Because these lines are parallel. What we have here are a set of corresponding angles. This angle here and this angle are corresponding. Same thing with this. This angle and this angle are also corresponding. If you remember back with parallel lines, corresponding angles are congruent. So, this is also similar with these triangles. This is also due to the angle-angle postulate. Keep in mind, folks, if you do not see any side lengths on your triangles, that means that you are most likely going to have to deal with the angle-angle postulate and be able to prove it using this, okay? You're looking for two sets of angles, one from each of the triangles to really determine. Now, over here, you see that we have some side lengths, finally. So if we have some side lengths here, that means that we have to go through and prove whether or not these are proportional. So, we got 16 and 16, we got 36 and 36. And we also got this other thing that we have to keep in mind. Since we do not have three sides here, that means that side, side, side is not it, okay? So let's just keep this in mind. All right. So we are not going to be using side, side, side for this because there aren't three sides. We are also not going to really use angle, angle because we don't have another angle that we can determine is the same. There's no other markings on our angles here, folks. So we got to go through and do some math. So first off, we got this angle here in the middle. This angle here in the middle, in between these two triangles, this is, if you remember from way back when, a vertical angle. So this is a vertical angle right here, this and this. That means that these two are congruent. Now, next thing we got to check, are the sides proportional? So we got 16 and 16, we got 36 and 36. Obviously these two are equal right now, and they both are included on this angle that is inside of our two triangles here. So if that is the case, we got a side, an angle, then a side, and a side, an angle, then a side, which means, yes, these are similar due to the SAS theorem, side, angle, side theorem. So remember, for the side, angle, side theorem, or if you end up dealing with the side, side, side theorem, you are going to have to be able to show the math involved with this, okay? For the angle, angle theorem, you have to be able to prove that we have angles that are congruent. So in the case of A, you have to go through and, do some math, some subtraction to go through and figure that out. Or in the case of B, be able to tell us what's happening with the terminology that we know. These are parallel right here, so that means that we can go through and say we have corresponding angles, and also these two triangles have this top one that is the same. All right, that was a mouthful. That's a lot. All right, let's go through. Let's hit this next one. All right, next thing we got to know. We got some proof writing tips to help you out. So first off, ask yourself, what do I know about the situation, okay? Next thing, fill and mark all known information on the diagrams. Then finally, well, not finally. Next, we got a highlighter and color code any corresponding parts that can help you, just notice what's going to match up with what. And finally, we begin the proof by filling in all the given information. So these are just a couple different things that you can use to help you out with proofs. Proofs have a lot of information involved with it, so you have to make sure that you're keeping track of all the stuff as best as possible. Indicate any information that you have, use the given information, and just work from there, okay? All right, let's go through and do a proof together, folks. All right, folks, so let's jump into a proof together. So most of our similarity proofs are going to involve you proving that the triangles are similar, and we need to use the shortcuts we talked about. So that's angle, angle, side, and side, side. This is also going to use all the other vocabulary we've dealt with triangles up to this point. Remember, the three angles inside of it add up to 180. You also know how to go through and set up a proportion. If you're doing that, you have to make sure that you're using the sides that should match up with each other. All right, so here's our first proof. It gives us that line BC is parallel to DE. And they want us to prove that triangle ABC is similar to ADE. All right, so first thing I want to mark is that these two triangles have these lines that are parallel. Next, I also want to keep in mind what the triangles are, in fact, okay? We got this top one right here with ABC. That's our small triangle. Both of these triangles overlap. So we got ABC in red, we got ADE in black. Things to keep in mind. Look at the names, okay? We see A's popping off. And if you look at them, they both got A in the same place. So that's one thing that we can go through and determine. We got this A here. This is talking about this angle that I'm highlighting up top. That means that this angle is the same. So let's go through and start off our proof. All right, first off, we know that these two lines are parallel, BC and DE. That's given to us. Next, we talked about angle A. Angle A shows up in both of our triangles' names. So angle A is congruent to A. And what we're going to do is we're going to use this. This is the reflexive property, okay? Remember way back when we were dealing with proofs, anytime you say that something is congruent to itself or something is equal to itself, that's using the reflexive property, okay? So we got two bits of information here. Now, note, we don't see any sides here. So since we don't see any sides, we should start looking for another angle to pop off with this. So we're dealing with parallel lines, so we have some corresponding angles. I just highlighted two ones right here, D and B. So we can go through and say that these two angles, ABC and ADE, are congruent. This is because they are both corresponding angles. This is the corresponding angles postulate from way back with parallel lines that we were dealing with. Now, we have two angles. Both of these triangles have angle A that's congruent, and we also named these two angles are congruent. So that means that we have proven what we were trying to prove. What we were trying to prove was that ABC was congruent to ADE. Well, the triangles. I know these two kind of match up, but this is talking about the angles. This is talking about the actual triangle. And then finally, this is because of the AA postulate. Okay? All right. So, next thing we got right here. We want to make sure that we follow through with some of the stuff that we did with our tips. Look at our triangle. Look at the information they give you. If you don't see any triangles with numbers around its sides, that means that you are not dealing with side, 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 or side, angle, side. You are dealing with angle, angle, most likely. Now, you will be able to go through and determine if the sides are corresponding and, what is it? What's the name of the word? What's the word? I'm blanking on that. If they're corresponding and proportional after you prove that these triangles are similar. So if you do prove that two triangles are similar, you can go through and piggyback on some of the other stuff. If the triangles are similar, they got corresponding angles that are congruent, and we have proportional sides. So let's see that pop off in action on our next proof. All right, so this time we're going to be proving that side lengths are proportional. The last one was just proving that the triangles were proportional. So this time, another common similarity proof you'll be asked to write involves proving that the side lengths are proportional. To do this, we have to first prove that the triangles are similar. All right. So, first thing we got to do, we are trying to prove that RQ over TU is equal to QS over US. So, first things first, let's go through and highlight some information. The given information they tell us is that R is congruent to T. So this angle and this angle are congruent. So we got this. We don't see any sides written here. We're trying to prove that these side lengths are actually going to be equal to each other, which means that once when we go through, it has some other information that'll help us out with this. We can go through and actually prove this. So, first off, we always start with your given stuff. So, angle R is congruent to T. That's given. Next, we're looking for another angle here that can help us out. So, if you look at our two triangles here, we've dealt with something like this before. See these two angles here where S is at? These two are an example of vertical angles. Remember, if you got two lines that cross like this, they make up two sets of vertical angles. The top to the bottom, the left to the right. So, these two angles are the names of our vertical angles. We got QSR, so from Q to S to R, and then we got UST. These two are congruent, and that's because these are vertical angles. All right. We already got some of our stuff that we need to prove that these triangles are congruent. So, triangle QRS is similar to UTS. So, that is because we got two sets of angles that are congruent. That's the angle-angle postulate. Now, we only got one line here, and that's going to be for what we're trying to prove. So we're trying to prove that RQ matches up with TU and QS matches up with US. Now, if you've proven that the triangles are in fact similar, this last thing that we're trying to prove will go hand in hand with that. So, this proportion works because the corresponding sides of similar triangles are proportional. One thing I want to make sure that you're aware of, when you're naming these triangles to prove that they are in fact similar, you want to make sure that you name them according to what angles are going to be what angles are congruent to each other. If you know, S and S are both in the same place, R and T are in the same place because they both are already congruent. And if these two are marked the same and these two are marked the same, these last two angles that weren't marked have to be the ones that match up. That's why Q and U are going first in both of these. Okay? So, we got one last one that we want to do. I'm going to help you out with the beginning parts of this. Then I want you to pause it and then try it out. All right, so beginning parts of this, it tells you that JK is parallel to NM. And they want us to prove that triangle JKL is similar to NML. So, first thing you want to know, you got two parallel lines here. Remember, parallel lines are going to make up some types of angles that you would like to use to make this be what we need. Now, you're going to pause it for a second. So, give it a try. We know what you need to put in first. You also know what you want to put in last. You're going to need some information in between it. There's only 4 steps, folks. All right? Come back in a few. All right. Now we're back. So, first off, we got our given information. JK is parallel to NM. That's just given to us. Now, because of that, we need to now go off and start finding some stuff that's going to make our triangles similar. We don't see any side links, so that means we got to start working with angle. So let's take a look at some stuff. All right, here's 2 angles here. These are going to be congruent to each other. Why are they congruent? And that is because they are vertical angles to each other. We've seen this before, folks. We've seen this. All right. Next, we need another angle that's going to work for us. We got 2 parallel lines, so that means that we got a set of angles that can be congruent. So we're going to use these 2. So angle KJL and MNL are congruent. Now, these aren't corresponding. These ones are actually alternate interior angles, okay? That's because they're both on the opposite sides of this line here. Think of this like this would be the transversal line from back when we were dealing with parallels. If you don't remember what I mean by that, when we were dealing with parallel lines back in I think it might have been December. Might have been December. We had these two lines that were parallel, and then we had this line that slanted through both of those. This line here that slanted through both of those lines is the same thing as this line from J to N. You also have another example of that over here from K to M. But these are just, ways that you can look at it. Okay? So, you can say these two are congruent. You can also say that this angle here and this one down here are congruent. It's up to you for which ones you wanted to choose. So, we got two angles. That means that our two triangles are, in fact, similar because they have two angles that are congruent to each other. And that's about it. Nice, short, easy peasy, breezy notes. So, folks, you got some practice problems that you're going to be hitting up in class. Hope you do good with those. And I'm going to catch you later. Okay? Have a good night or morning or whenever you are seeing this. And see you.